Hi everybody, it's either Thursday or Friday when you're watching this, so go ahead and title your notes using reference angles on the unit circle. So what we're going to be doing is combining our knowledge of reference angles and the unit circle that we've been doing for the past 2 days. So let's go ahead and jump right into example 1. All you need to write is example 1, tangent of negative 5 pi. Now for this homework, you're again going to have to draw it. So I'm going to make a quick sketch of what this would look like. So tangent of negative, meaning going backwards, 5 pi. So I'm not even going to convert it to degrees. Could I? Sure. Negative 5 times 180. But I know that pi just means 180. So I'm going to go 5 of them. 1 pi over 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. Right there. I land right there, which means I'm landing right here. So I have already found what I need from this one drawing. It tells me that the information I need can be found right here. Essentially, this is my reference angle. Now, reference angles, again, have to be acute and between 0 and 90, but the goal, the way we're using reference angles, is just to find where does it land on the unit circle. So now I can actually calculate, which is what this question is asking, tangent of negative 5 pi. So this is different compared to the other days because we had to go around the circle either backwards or more than once. But once we can figure out where we land on the unit circle, the rest of this is easy. So how do we find tangent of negative 5 pi? The same way we did on Wednesday's video. Y over x, y is 0, x is negative 1. It is okay to have 0 on top. My final answer is 0. So tangent of negative 5 pi is 0. Let's try another one. Okay, go ahead and write down sine of negative 17 pi over 6. So what makes this problem more difficult than the ones we did before? A couple things. First of all, it's in radians. Whenever it's in radians, it's more difficult. Second thing, it's going negative, so I have to go backwards. Third, it's bigger than one time around the circle. I know 12 over 6 reduces to 2. This is more than 2. So you can convert this to degrees to help you out, like you always can. And the quicker you remember, pi over 6 is 30, negative 17/30s. But I always challenge you to try to do these problems without converting to degrees. So let me show you my thought process on this without converting to degrees. Here's what I think. Okay, I know I have to go backwards, and I'm looking at a denominator of 6. This is 6 pi over 6, because 6 over 6 is 1. This is 1 pi. And then if I keep going, I end up at 12 pi over 6, because 12 over 6 reduces to 2. Okay, well, that's not good enough. I need to keep going. So I need to go another 6. So I'm going to go another 6. So 12 plus 6 is 18 pi over 6, which reduces to 3 pi. Still not good enough because I need to, oh yeah, that is good enough. Because I don't want to go to 18. So I'm going to literally erase a little bit of that. If I can find my eraser on here. So I'm going to erase a little bit of this. I went a little too far. So I need to just go right here. Okay, now you want to think about what is the reference angle. Remember, the reference angle is this space right here. Well, it also translates on your unit circle. So what value are we using for our unit circle? We're using the values right here. 210 isn't our reference angle. This 30-degree gap, or pi over 6 gap, is going to create the same numbers as this. So I found the equivalent spot on my unit circle, and that gives me enough information to complete this. So just to be clear, sine of negative 17 pi over 6 has the exact same sign as 7 pi over 6. And what is sine? Sine is the y value. And which one is the y value? So let me write out the coordinates I'm looking at. I'm looking at the square root of 3 over 2 and negative 1/2. The y value is the sine, and that's the one I want. So the sine of negative 17 pi over 6 would be negative 1/2. And that corresponds with all students take calculus, sine is supposed to be negative in this quadrant. So what's sine of 7 pi over 6? The exact same thing, negative 1/2. What's sine of negative 17 pi over 6? The exact same thing. There's lots of ways to get here. Imagine just keep going around this circle and coming back here. It'll still be, sine would still be negative 1/2, or going backwards and coming to that spot. It's about where you land, and then you want to look for those points. Let's do 2 more. Okay, go ahead and write down cosine of 21 pi over 4. So it's not hard to find the cosine. We know cosine goes with x, so I'm looking for the x value. The problem is I don't know which one of these to look for. Okay, so then that's why the first thing always says to draw it. So you could convert this to degrees. Pi over 4 is 45, 21 45s. I'm always going to challenge you to not try it that way, but rather just start thinking in radians. So I don't know how many degrees this is. Sure, I could easily figure it out, but instead I'm going to start counting in degrees. I'm going the positive way. 4 over 4 reduces to 1. 8 over 4 reduces to 2. So I've gone 1 circle so far. I'm not at 21. I'm going to add 4 more. 8 plus 4 would be 12 pi over 4. Still not good enough. 12 plus another 4 puts me at 16 pi over 4. Look at these numbers. 4 over 4 is 1. 12 over 4 is 3. 8 over 4 is 2. 16 over 4 is 4. Evens, odds. Let's keep going because we're still not at 21. If I add 4 more, I'll be at 20. So 20 pi over 4. 20 over 4 reduces to 5. Okay, am I there yet? Nope, I need to go 1 extra pi over 4. So 1 extra pi over 4, and this is the drawing of this angle. Now, we already learned drawing these angles before. How does this help us? It actually gives you the reference angle. Right here, this space right here is the reference angle. That's a pi over 4 reference angle. But on our unit circle, I see it as this space right here. This is what I'm looking at, this 45-degree space, which means I'm looking at this info right here. This circled purple info. And what coordinates are those? Negative square root of 2 over 2, comma negative square root of 2 over 2. And which one is cosine? Cosine is x. So what is my answer to this question? Negative square root of 2 over 2. Let's take a minute to understand what just happened. Again, we traveled around the circle many times, ended up here with a 45-degree or pi over 4 reference angle, which I'm using also right here. There's the 45 degrees or pi over 4 reference angle, and that's where these numbers came from. So again, if you kept going around the circle like this, it doesn't matter how many times you go, the minute you end up right here, back at this spot, you'll be using these numbers. Or you can travel backwards, go backwards this way, and as long as you end up at this spot, you will use these numbers as your reference angle as your value. So cosine of 21 pi over 4 is equal to the square root of 2 over 2, same as 225 degrees. Same exact thing as 225 degrees. Okay, let's try one last example. Let's go ahead and find tangent of negative 7 pi over 3. Again, we're going backwards, and I challenge you to not do this in degrees. Would it be hard in degrees? No. Negative 7 times 60. Negative 7 times 60. Okay, but you know what? I'd rather you practice in radians. So I'm going to look at this and know I'm going backwards. I look at the denominator 3. So this would be 3 pi over 3. And this would be 6 pi over 3. So if I go backwards, there's 3 pi over 3, there's 6 pi over 3, and I'm going an extra pi over 3 past 6, 7. So I end up right there. There's my drawing of my angle. Where's my reference angle? Right here. What is my reference angle? Pi over 3. How does that relate here? I need to find the equivalent reference angle right here, the pi over 3 spot. So what am I looking at to find my answer? Like I did Monday, Tuesday, I'm looking at these values, and then from there, now I need to figure out what is tangent. So tangent of negative 7 pi over 3 will be the y value over the x value. The y value is negative square root of 3 over 2. The x value is 1/2. I need to flip the second fraction and multiply. So negative square root of 3 over 2 times, so take the first fraction, negative square root of 3 over 2, multiply by the second fraction flipped over. The 2's cancel. Square root of negative square root of 3 is my final answer. So tangent of this yellow spot is the same as tangent of this yellow angle. And anything that lands, so we could land, again, we could go around the circle this way, we could go around the circle backwards, but the point is the minute you land here, your tangent will be the same. So we have just combined everything we've learned. We have done sine, cosine, and tangent. We've done drawing them, reference angles, radians, degrees. So if you understood these 4 examples pretty well, then you're understanding everything we've done in trig very well. If you're not, I strongly encourage you to look back at the last couple videos and see if you get a better idea of them. So go ahead and start assignment now. There's 10 problems similar to these.